This is the 2.6 RSG. So I'm going to talk to you about the first chunk. So this whole table is helping you compare two equations. We've got one here, and you've got another one here. So the first, number one, it wants to know what type of growth. So the answer here would be linear or exponential. One of them is linear and one of them is exponential. It's hard to read with those highlighting. The second one says type of sequence, so that's arithmetic or geometric. One of them is arithmetic and one of them is geometric. And then since both of the equations, they have just plain x, not x minus 1, they both start at 0. So give me your starting output here, and then do the action that was given. Rate of change is either the common difference or the common ratio, and then make a graph. And then the y-intercept is that starting output. So that is this point in the table. When the input is 0, what is the output? That's what we're looking for 1 through 6. And then remember, anytime they say y-intercepts, that's the starting output at 0. The set is a lot like the task for 2.6. It gives you a situation and it asks you what type of form should we use? Should we use slope-intercept, which is when it starts at 0? Should we use point-slope when the starting input is not 0? Would we use a recursive or an explicit and a recursive and exponential? So number one says, Jasmine's been working to save money and she wants to have an equation to model the amount of money in her bank account. She's been depositing $175 a month consistently, so that tells me that it's adding 175, that's my action. But she doesn't remember how much money she deposited initially, which would be at 0. However, her last statement, she saw that her account has been open for 10 months and she has $2,475 in it. So since this equation does not start at 0, I would not use slope-intercept. I would use point-slope. It's great when your equations don't start at 0. And so I would say she has, what we know the output is 2,475. That's my starting output. And we know the action is to add 175, because that's how much she's doing consistently. And then per month, and then I'm going to minus the starting input, which the starting input on this one is 10. So this is an excellent opportunity to use point slope. We know this is our output, we know this is our action, and then we're going to do in minus the input that went with that output that we had. Point slope. So you use point slope if you have a linear example that doesn't start at 0, and you use slope-intercept if it starts at 0. This one, 2, 4, 8, 16 is geometric or exponential, so we would use the explicit. So you just say which type you would use, and then you write the equation for the situation for all of those. And then the go is solving equations. So remember you're trying to get x by itself, and to do that you're undoing any operations. So 15 says 3x equals 15, that means 3 times x. So first I'm going to undo that multiplication by dividing both sides by 3. And that is the division property of equality, because we're undoing the multiplication. And then I get x equals 5. 16, I have x minus 10, so to undo that I would add 10 to both sides, and I would get x equals 12. And that was the addition property of equality, because we added 10 to both sides. There are some videos in the formative. If you're struggling with these problems, please watch those.